welcome to the Absolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap math reminders. Let's zoom out. Math? I thought this was science. The AP Biology equations and formulas sheet is not only readily available online, but also 100% allowed as a reference during the test. Grab your numbers, plug them in, and get your answers. But numbers will only get you so far. Interpretation and application of the numbers is where understanding comes in. And please, for me and all of your science teachers, always include units with your answers. Let's zoom in. First up, surface area to volume ratio. This correlates to topic 2.3, cell size. This ratio affects the ability for a biological system to obtain resources, get rid of waste, release thermal energy, etc. The challenge is that volume increases at a faster rate than surface area. Organisms must efficiently exchange chemicals and energy with their environment to maintain homeostasis. This concept also applies to cell compartmentalization. Consider the inner folds of a mitochondrial membrane. The more folds, the more opportunities to build up that electrochemical gradient of hydrogen ions. Surface area to volume ratio is dependent upon the shape of the cell. Yes, not all cells are spheres. This math sheet contains the formulas for spheres, rectangles, cylinders, and cubes. Plug and play, then apply your numbers to the biological concept, most likely a cell transport question. Next, water and solute potential. This matches topic 2.8 on tonicity and osmoregulation. Okay, so this is the potential to do what exactly? Water potential equals the pressure potential plus the solute potential. Water potential is indicated by the Greek letter psi and looks like a trident. Remember, your numbers need to have meaning. Your numbers help to explain how concentration gradients affect the movement of molecules across membranes. The greatest value that water potential can be is 0 with pure water. Therefore, any solution that has solutes in it will have a negative value. The solute potential of a solution is equal to negative I CRT. I, the ionization constant, is equal to the number of particles the solute will make, or ionize into, when in water. For NaCl, this would be 2, whereas for glucose, which doesn't ionize, this number is 1. C equals the molar concentration. This is often from experimental data, where the line of best fit crosses the x-axis. R is the pressure constant and is always equal to 0.0831 liter bar per mole K. And lastly, T. You know this one. T equals temperature in degrees Kelvin, which is 273 plus the calculated value in degrees Celsius. Do not memorize any of this. It will all be on the math sheet. You may have to first solve for solute potential before solving for water potential in a given problem. Moving on to the laws of probability. This is relevant to topic 5.3 with Mendelian genetics. Pop quiz. What are the chances you will get a 5 on the AP Bio test? The grading scale is out of 5. Therefore, a 1 out of 5 is 20%. Thankfully, AP scoring doesn't work this way, and you've been listening to the Absolute Recap, so the odds are more in your favor. The rules of probability can be applied to follow the passing of a single gene trait from parent to offspring. If A and B are mutually exclusive, then add their probabilities together. If A and B are independent, then multiply their probabilities. So what is the probability of flipping a coin and it landing on heads twice in a row? Or 2 heterozygous parents having an offspring that is homozygous recessive consecutively? Punnett squares model the probability of alleles recombining during fertilization. The remaining math recaps for this episode have applications in more than one unit of study, as they are used to statistically analyze data. Standard deviation is a measurement of how spread out data points are. In standard error of the mean, the standard deviation value is divided by the square root of the sample size, or n. For the purposes of the AP exam, students will not be required to perform calculations using the standard deviation or standard error of the mean equation. However, you must understand the underlying concepts and applications. When graphing error bars in AP Biology, students must indicate plus or minus 2 times the standard error of the mean. So, if my standard error of the mean is 1.5, then I need to graph my error bars as 3 above and 3 below the average. If 2 error bars are overlapping, then there is no statistical difference between the variable groups. Essentially, the data is too spread out from the average to say that the groups are distinct. Closing out with chi-square. This statistical test compares your observed experimental data with an expected calculated outcome, determining if differences are just due to chance or another influencing variable. In statistics, a significant difference means there is less than 5% chance that the variation in the data is due to random events. Therefore, the variation is most likely due to an environmental factor. A common scenario is to be given observed phenotypic traits where you must figure out the expected through a Punnett square. Observed, expected, sounds like chi-square. Once your value is calculated, again, check the math sheet and remember your PEMDAS rules. Compare your value to the chi-square table of critical values. You will find the column of your degree of freedom and the p-value row of 0.05, or 95% confidence. Your degree of freedom is equal to the number of distinct possible outcomes minus 1. So if there is an option of heads or tails in a coin flip, then the degree of freedom is 1. Chi-square values are often used to reject or fail to reject a null hypothesis. If the calculated chi-square value is smaller than the critical value, we fail to reject our null hypothesis because our data is consistent with what we would expect. Any slight difference is just due to chance. If the calculated chi-square value is larger than the critical value, we reject our null hypothesis because our data is too different from what was expected to explain the differences by chance. There must be some other explanation. Other math topics, like Hardy-Weinberg equilibrium and Simpson's diversity index, will not be included in the 2020 exam, as these apply to evolution and ecology respectively. To recap, yes, there is math in AP Biology. Have your calculator handy and check your equations and formula sheet. Always make your math have meaning through analysis, biological application, and units. Today's question of the day is about symbols. What is the Greek letter for summation? For the answer to today's and future questions, please follow us on Instagram at TheApsoluteRecap. That's the APsolute recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020 Absolute Recap LLC, all rights reserved. Coming up next on the Absolute Recap Biology Edition, it's Listener's Choice.